Let's start with emails. Because I don't want to do anything else right now. I'm very curious how many emails I sent out this week. $79 last week. I think we're breaking like 100. Calendar. On the 17th. Okay, there's a lot. I didn't send any on the 17th. I sent them on the 18th.
Wow. 101. 102 actually.
We run a pre-order depth first search on the root of a binary tree. Pre-order? What's that? Pre-order versus post-order. Pre, so we go 1, 2, 5, 3, 4, 6, 7. 1, 2, 5, 3, 4, 6, 7. 1, 2, 5, 3, 4, 6, 7. Or is it 1, 2, 3, 4, 5, 6, 7? We put D dashes where D. Then we output the value of this node. If the depth of node D Hmm. 6. So we're just reconstructing it. Okay. What are the values? Okay, so they can be massive. First value will always be the root. How do we do this? It has a really high acceptance rate. I'm thinking about how to break down the traversal string. Wait, I'm dumb.
These dashes mean nothing. Yeah, these dashes mean nothing. You should do a post order on this. Actually, how do you know when it stops? Maybe these dashes do mean something. How do you know when it stops? Ah, shoot. How do I do this? I actually don't know how to solve this. I'm looking at the hint. That doesn't help. I was going to do that. Okay, let's just start typing. Jeez, I don't know what I'm doing here. Stack? Oh, jeez. This was not easy for me. Okay, I got this right. I honestly could have figured this out.
What? Bruh. I don't increment index, huh? Do they do it here? Yep, they do. Of course. Missed that. Yeah, I probably could have figured that out. I was overcomplicating it a little bit. Okay, now what? I need to do something. good.
As an owner of Walton Goggins goggle glasses, I know how to make slick-looking goggle/glasses. But I have no idea how to make slick social media-styled stuff to sell it. But GoDaddy Aero uses AI not only to create social content out of...
Are you ready to ace your next technical programming interview? In this video, Keith Galley conducts a mock full...
Optimize it and write code or pseudocode.
Are you ready to ace your full-length, real-world coding technical interview with Kylie Ying for a software engineering role? Learn how to use object-oriented programming and dynamic programming to solve questions and get the job you want.
Most people will probably agree that one of the worst parts about finding a job as a software engineer is the technical interview. During these programming related interviews, the interviewer will expect you to work to a solution, optimize it, and write code or pseudocode on the spot. The reasoning behind these interviews is that they will help the interviewer understand your ability to understand the problem, ask questions, go deeper, and optimize the solution. How much do you understand data structures and algorithms? And ultimately, what is your coding level and what is your coding ability? Today, I paired up with a good friend of mine, Keith Galley, who has a data science focused YouTube channel, and he is going to be mock interviewing me. So this interview might look like what a real software engineering interview looks like. I don't know what question he's gonna ask, so it's gonna be as much of a surprise to me as it is to you. And I will be coding on the spot, so here we go.
Welcome. Welcome to the interview. How are you doing today?
I'm good. How are you?
I'm doing pretty well. We're going to probably just jump right into this interview. I'm just curious, are you familiar with CoderPad? Because that's what we're going to be using throughout. I think it might be easiest to kind of share code.
Yeah.
Cool. All right, so we're going to kind of just jump right into the problem. So for the purpose of this problem, and let me share, I just want to make sure you can access this coder link. So I'm going to share this, and I recommend maybe sharing your screen, or I guess we also can just work off of this. So I should be able to see what you typed in.
If I open the chat, I can click on this link, and it'll take me to the CoderPad. My name is Kylie, and I will enter. And so I can see that you're in this CoderPad as well, and then here I am.
Yep, and
Okay,
just to make sure that you're comfortable here, you want to just run like a couple simple lines of code. You can try just running this print hello world if you want.
Yeah, so if I run this, it'll say that I ran a line of Python, it prints out hello world. So I think it works.
Perfect. Okay, so let's kind of jump into the problem. So just to give you some context, we're going to start with about 20 minutes of design, object-oriented design, however you want to design this code. And then we'll spend probably the last 20 minutes working on more of an algorithms question. So that gives you just a little bit of scope.
Awesome.
You don't necessarily have to accomplish everything. You know, I know that we have limited time. But to kind of give you the context of the problem, imagine that we're designing a book system, so an online cloud reading application. And you can pretty much imagine that we're building a product that is similar to an Amazon Kindle, but specifically for short stories. So we're kind of in our own niche. They might be indie stories. They might not be, found anywhere else. People could add their own stories. And basically what we want to do to start this problem off is that we need help designing the actual application. We need help designing the code that could implement an online cloud reading application. And there's a couple things that we're looking for. And this is very open-ended. You can implement this how you want. But a few things, and I'll paste these into the CoderPad that we're looking for. I'll just paste it below. Okay. You can fix this up. And I'll delete that top line.
Okay, so a few things that you're looking for. Users have a library of books that they can add to or remove from. Users can set a book from their library as active. The reading application remembers where a user left off in a given book, and the reading application only displays a page of text at a time in the active book.
Exactly.
Okay. Awesome. So let's see. Essentially, what we want to do is create a library where users can interact with this library. They can look at a book and set it as active, and then this application will also just remember where they left off and display whatever page that they're currently looking at in the active book.
Exactly.
Is that correct? Okay.
Correct.
Okay, and then more specifically, do you want me to kind of give like a high-level implementation, or how do you want me to start this?
So I really want to just think about, what components would be important. This is, I would say, an object-oriented design question. So I'm just thinking about how you would think about structuring, I guess, the base of a program like this. So obviously, we're not going to build this full application, but I'm really curious about how you're structuring that core structure, that core foundation.
Right, so let me make this smaller over on this end so people can see all of this. And let's type up some more notes. So the things that jump out to me are that you need to be able to remember all books. So if I type this, we need to have all books in the library, and we need to remember active book. And then we want to remember page, I guess last pages in all books. And then we want to display a page in active book. Okay, So by this all books in the library, is that more so, I guess, how are we representing these books? Are they just like strings? Do they have a page number and then the string of text? How is that formatted? Is it like HTML?
I think it's up to you how you want to store the books within like this programming structure. So you can kind of decide what makes sense for that. I think the important things is the actual text of the book, as well as the title of the book.
Okay.
And you can implement
so-
the details of like the pages and all of that.
Yeah. Okay. So I think that there's two things that jump out to me here, right? We need one class. We want one class representing a book, and then we want another class perhaps representing a library, so a collection of books. And so in this book specifically, you just mentioned that we want the title as well as the like pages in the book.
Yep.
Or like I could rename that the content.
Yep. Exactly.
In the book. And then for the library, we have a collection of books. And then I would also argue that this page, that whatever the active book is would be at the library level because we just want to toggle which one is active amongst this entire group, right?
Yep.
And then actually, so this last page in the book, I think I'm going to put that under the book because it's book specific. So I think it would make sense for every single book to just remember the last page. So, user looked at. Okay, so I like how this is represented, and then I think kind of diving more so into the implementation.
This is the complicated stuff. Like a user has to eventually interact with the library, and through that the book. So are we allowing the library to be used by multiple users? Is there just one user? Is it like if it's a Kindle, then am I just accessing the Kindle and then I have a library of collections that I can read from? Like,
I think for the title, a string would make sense here because, I mean, a title is just a string. The pages and the content in the book. So the things here are the pages are ordered, right? When you go through a book, they're ordered, and there's a specific amount of content per page. And so I think something that would make sense for this is just a list, because I think a list is ordered. It's a collection of items, and we can't. I mean, I think like a set, you would lose the ordering. A dictionary, you would lose the ordering, and you would also overcomplicate things a little bit. You could have the page numbers as the keys, but then a list would also do the same thing, but kind of in a more elegant manner. Yeah. And then finally, a tuple. Okay, you could also have a tuple, but I don't think there's a reason to use like a tuple over a list in this specific example.
Yep.
Or like vice versa. Like I think that you could choose from either one.
Mm-hmm.
So I think here I'm just gonna use a list of
strings.
I guess strings, which represent per page. So like each string represents whatever's on an entire page. And then the last page that the user looked at, this would just be some integer, and this would be an index into this list of strings. So I would have to remember that this, there might be an off by one error here, because in Python we start at 0, but like naturally when we're reading a book, we might start at 1.
Yep.
Now for this library, for this collection of books, so for this active book, you could either use a Boolean where you set one book to active and the rest to inactive, but I think that would be kind of excessive because every single time we toggle a book as active, we have to toggle everything else as inactive, right? You can't have 2 active books.
Yeah.
Okay.
Yeah, that makes sense.
Okay, so then I think in that case,
2 active books. That's so dumb.
Instead, what I would
okay, I need to walk through this. So if we don't want to use a Boolean to flag the one active book in the massive library that we have, the drawback to that is that we have to parse through all of the other books in the library to make sure none of them are active. What we can do is just have the title of the book or the ID that's associated with that book at the library level to indicate which one's active. So when we set a new active book, we just replace the ID or that title.
Rather do is have some sort of a string or some sort of like an ID matching system where we have one variable that's set to the active book, and that might be the title or the ID of a certain book in the library. So maybe we can just add ID here. and maybe I can make that also a string or an integer or something.
Yep.
And I'm going to add a question mark to kind of just say like, maybe we could implement that, but I'm not sure if we'd want to right now. So this would correspond to ID. So
Correspond to ID.
this would just be some variable. And then this collection of books.
Hash map. Dictionary.
So
Same thing.
I guess like when we
ID.
display this page in an active book, I think that this might have an advantage being like some sort of a lookup table because we have
There you go.
a certain sense of an ID, right? And I think what could make sense here is having the ID correspond to the book object
Yep.
Yep.
that we define up here.
Beautiful.
So this could be a book object,
Yeah.
right? And so
Beautiful.
we don't really need this ID. I think that if all the titles are unique, then we don't need this ID. We can just use the titles
That's assuming
as the
titles are
IDs.
unique, though.
But in some cases, in the real world, not all titles are unique, and so that's when an ID might come in handy. And so I'll leave that like. What are our assumptions here? Can we assume that the titles are unique, or should I be using this ID structure?
I think I like the ID structure because, we're not necessarily
Okay.
going to know that everything's unique, so I think
Alright,
this
he's
is a little
making it
bit more
hard.
robust.
Okay, awesome. So I think this representation looks good to me. So I'm just going to go through the requirements again, just to make sure that I've covered all my bases. So here I want all books. Okay, so I want a library of books that I can add to or remove from. And so here I have a library, and anytime I want to add to this library, I can just add an ID, I can add the book. If I want to remove from the library, then I can just simply delete the key item pair. Or the key, whatever pair, key value pair. I can set a book from their library as active, and so here I have this active book, and we could always say like if there is no active time I want to add to this library, I can just add an ID, I can add the book. If I want to remove from the library, then I can just simply delete the key item pair. Or the key
Strings.
I guess strings, which represent per page. So like
I didn't realize that this was on.
book, then we set this to none or something like that. Or the key, I guess strings, which represent per page. So like,
I didn't realize that this was on.
book, then we set this to none or something like that.
Okay, now we're chilling, which is fine. Maybe I could do this. I forgot I added this again.
The reading application remembers where a user left off. So we have that here, right? The last page that the user looked at, and not just in the active book. And then
Oh, that's
displaying
pretty
one
neat,
view of text
actually,
at a time
'cause it's
in
on the
active
book level.
So we have the active book. We can get the book object from that, and then we can go to the page that the user last looked at by indexing this value into this list. So I think we've covered all the bases here.
Cool. Let's do a couple things. I think as a starting point, and this doesn't have to get too crazy, but I would love to just see some, Python pseudocode or even some Python kind of code, just to like maybe flesh out one of these classes. I just want to, look at that a little bit and how you would actually start writing this code.
So start with the library.
Yeah, sure. So for example, here
Class,
let's start with the
library.
book.
No, bro. Why would you start with the book?
And when we define a class, let's initialize this.
So we're gonna initialize the ID.
So when we initialize a book, we definitely should pass in the title and then the content, right? I'm assuming that when we add a book, these things
You
have
pass
to
an
be
ID
given to
too,
us.
bro, because you
And
want to
then-
manage the ID on the library level.
I'm assuming that when we add a book, we don't have a last page that the user has looked at. Is that an okay assumption?
Yeah, I like that assumption.
Okay.
Brother.
So we can set
Where's the
title of
ID?
book just equal to whatever the title is.
Sure.
The content
Content
of this book.
equals content.
And I'm going to assume that these are given to us in the formatting that we want. So the title is a string and the content is a list of strings that correspond to the pages. And I'm going to create a
Last
variable
page equals 0.
and I'm going to set that equal to just 0.
Bet.
I could also probably set it equal to -1 or something, but I think 0 makes sense because that would be the
0
beginning,
totally makes sense.
right?
Yep.
-1.
And
Shouldn't even consider that.
And then we need to come up with some sort of an ID. So typically, maybe we would have some sort of function that takes in the title and the content, or maybe the author or something, and like returns a unique ID.
No.
I think
You literally,
do here just very
what you can do very simply on the library level, keep a book count tracker, and then make each book, just increment that and make it like a long or something like that.
simply is have some sort of counter in the library. And
Yes, sir.
we like add a new book. We can
So
just
pass in the ID.
that counter with that book, and so then we know that they're all unique and they all have their own IDs. Would that make sense?
Yeah, that makes sense.
All right, pass in that, John.
Pass in the ID. Yeah.
Self.id equals ID.
To self.id equals ID.
There we go.
And then, yeah, and so then, for example, we might want like a display page, right, in this book. And so for that, then we
Return content dot get this dot last page. Boom.
And I guess let's build on this a little bit. Another useful function, obviously you want to start at the last page, but let's say we're starting to turn the page. What might that look like?
Next. Def next.
Right, and so if we're
And then
turning
you-
the page, then all we want to do is increment.
Self dot last page plus plus, and then self dot return self dot content self dot last page.
And then we could call display page after that.
Or you can call display page. Yeah, actually that's pretty scalable. That's a lot
Like
better.
we could, if we assume that these two go together. So if we assume that when we turn the page we want to display that page, then I would just return display page.
That's kind of smart. Okay, I'll give her that. That's good.
And then actually I'm just gonna go ahead and code up this library as well.
Yeah, she's just going for it, bro. All right, what do we want to initialize? What are our instance fields?
This collection of books.
Collection of books, active book.
So
So
rather
active book is going to be a long or an int.
let's just add them.
So self.activeBook
So
equals
initially,
self.collection equals a dictionary. Sure.
and then the active book might be none, right? So then.
Oh, she says it's a
when
null.
we want to
I would have said to
add
-1.
stuff, so
Oh,
add
but
to
you know, we got a dynamically typed language.
book.
That wouldn't work.
What I'm going to do. So there's either the user could like, or our API could like return a book with the title and the content, etc. But since we said that we would pass the ID through like the library because we might have like a counter. Like
Self.counter
I mean,
equals
this is like
ID
a
counter
way to do it,
equals
like,
0.
this is like a fine hack for right now.
Wait, what did she say?
Like some sort of ID counter. I mean, this is not the best way to do it.
Yes,
but
I
this is
agree.
like a
I
fine
agree.
hack for right now.
For the purposes of the building the library,
We can
let's just do
also,
that.
When we want to add a book, just pass in the title and the content. And so then our new book is going to be a book, as we've defined above, with the ID.
ID counter,
And, the title. and
title,
the
counter, content,
And then,
and then we need to increment ID.
to increment the ID counter.
Yes, sir. Yes, sir.
And then we also want to add this new book into the collection, right? So,
Oh yeah, self.collection.add new book.
and I'm going to make the ID whatever the ID of the book is. So
Ooh, that's
yeah,
that's genius.
And this is going to be the new book.
Okay, that is a little bit cleaner. That is a bit
That's
cleaner.
adding to the collection. So of
Remove from library. You do the same. You do the opposite, bruh.
we said that we wanted to remove based on the ID. So all we have to do is, I think,
Self.collection.remove new.
in Python.
I'm not sure if there
I don't
is.
remember. Do you know, Keith? Okay. Is there a remove? Let's see.
I think that there's. I mean, it should autocomplete here in the coder pad.
Oh, isn't it Dell? Isn't there a Dell?
If you're paying
That was
someone
cringe.
a lot of money to micromanage your team's time, then you're probably wasting your budget
Bruh.
like I was. It either consumed all of my time or
I mean, I think the biggest thing is it going to be happening in place or is it going to be happening in creating a copy?
Wait. It's very interesting. When I play music, it doesn't go through. Maybe that's deliberate.
I understand.
Yeah, so we want it in place from
Yeah.
the collection.
I understand what you're trying to do.
Yeah.
So the exact details is not super important to me.
Okay. Yeah, so anyways, this is removing from the collection. And when we set active book, again, we want to do this based on
Self ID.
So
The self dot active book equals ID.
book equal to whatever that ID is.
Yes, sir. Yes, sir.
And
Display active book. You're gonna want to display the active book. What's the point of assigning an active book if you don't display it?
as active. Okay, and then remembering where a user left off. So we've actually taken care of that already implicitly in our book.
Bro, this
class. And then
Johnson's
the
easy.
application only displays a page of text at a time. All right, so then here we can say define display page. And actually,
Sure.
we don't even need the ID of the book because we already have the active book ID.
Yeah. So self dot or self dot collection, self dot active book,
I'm gonna get the active book. Like
and then display page of that.
Yep.
blah, 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 and I'm going to click, or I'm going to do dot display
Okay.
page.
Boom.
And then of course we also have this turn page that I could just put up as well.
Yep.
So you get the idea, but
Yep. Dot turn page.
so we want to, oops.
She's using those hot maps like I do, bro.
I do
Oh
think
my
that
gosh.
some like drawbacks here are that, okay, so
Wait, before she said, I do think it's weird that the library is just calling the book directly to turn the pages. So you have like turn page and display page in the library and the book itself. I'm not sure exactly how I feel about that. What would be a solution to that though? Oh, in your no, I feel like you should just do a read, like read and then display, like on the library level. You should do a read, like library.read, and then you display the book, and then through that you can. I guess that's the same thing.
is instead of this active book, instead of saving the ID, we could have saved the book itself. And I think from a Pythonic standpoint, that might make sense. But then in the future, if we're using some sort of database or something, an ID would make more sense because that's easier to store in like a table.
Exactly. That's a good point. That's a good point. If we're interacting with a database, you want to store the ID.
If and okay, also for this display page, you might see that we've called this display page and turn page up here in the book. And the reason why I did that rather than just call like self.book.content last page, like book.last page or something, was because I think that, like, for example, this should be independent of how we implement the book, right? So we want to keep those as kind of separate blocks as possible. And so here, what this allowed me to do is when I go back to my book, like if I decide to scrap this implementation, implement something else, I know that I would just have to implement the methods display page and turn page for that to work. And like these functions should work.
This looks good to me. I like the start. I think that this.
She's doing it for the scalability of the book itself.
With the requirements of this application. So nice work with this. Couple quick follow-up questions before we kind of branch into more of an algorithms type question as the follow-up here. One question is, let's say you have an older reader and their vision isn't as great, so they need to make the size of the font bigger. So kind of keeping that in mind, that you might have this variable font size. How might you, refactor or change?
Okay, font size. Should I do it on the book level or the library level? If it's the user itself, I'm tempted to say the library level. We could set the font of the library itself, and then pass in that to the view page function. You shouldn't do on a per book level. The more I think about it, so I would say add a fields to the library level that has reading font size, and then pass it in every time you view a page to be able to extract that. Now, then you would have to worry about pagination as well, which is a whole nother thing. Let's see if they have to deal with that.
By your current structure, and you don't have to actually write code here. Let's just discuss this to account for that increase in size.
Yeah. So when we increase something in size, like I'm just thinking about intuitively on our like phone screens or something, that tends to shift the content, right? So like some page that might hold 100 words or 100 characters at a small font size might only hold 50 if when we double that font size. So for the book, instead of having this list, what I might do is I might just save the entire book as a string. And
Oh damn! The entire book? I don't know about that, bro. I guess it's better for pagination that way, because you paginate on the API level rather than the data level.
Let me just edit this in here because I think it's easier to visualize what I'm saying. But so I might have like a font size equal to.
Honestly, I would just make it a scrollable window.
I guess we could just use like the traditional like
12
font or like whatever.
12.
But when we have this font size, we could come up with some sort of characters per page calculation, right? And so that would be based off the font size. So calculate. So this is going to be pseudocode now. This calculate doesn't actually exist, but calculate based on that font size. And I'm commenting it out so it doesn't have any errors. But then
when Google Fiber first launched 1 gig, it cost
$70.
okay, but today
when we do calculate that, then what we can do in order to get this display page thing would be, instead of indexing into this content, which is now just a long string of characters, what we can do here is we can return, we would have to do some sort of calculation, right? So we would need to, we have this characters per page, and
divide it by
whatever the last page is. And so this would give
you
us
have to
kind of
divide by
starting
font
index,
size.
long string of characters to start the content of that page. Start index would be this, and then what we would want to do is then return the self.content from that start index until the start index plus the number of characters on that page. So that would be our end index. So actually, let me just write that out to make things a little bit more clear.
Oh my gosh, she's typing so fast.
So now, essentially what I've done
It's like me.
is variable font size, which we can calculate characters per page, depending on
Oh, okay,
So
okay.
it might be more characters or less characters, depending on how big the font size is. And then our content, instead of a list of strings, is now just a really long string of characters. And I guess some assumptions that I'm making here are that this would just be approximate. So for example, if we had
You might get a cutoff
a
character.
line break, right? That might just end up counting as a character or 2 characters. But the assumption is that that would be approximate per page, or maybe that we're using some sort of like monospaced font or something like that. But essentially, now that we have the characters per page and then just a long string of characters that represents the content, we can index into that content depending on, like, based on the last page that we know. And so what's really cool here is that when we do turn the page, we can just end up calling this. So this is kind of that granularity that I was talking about.
Yeah, the scalability.
Definitely, you see the advantage of having that function that you can change by having to implement something different.
Right.
One last quick, I guess, follow-up, and then we'll move on to the algorithms portion of this interview. I'm just trying to think, at a high level, let's say that we had multiple users in this system, and they all shared books. So like, they might all share the Harry Potter books or something like that. Like, books are common among all of them. How might you modify this, given that, some of these qualities of a book might be shared between users because they're all trying to access that same book? Does that make sense?
Yeah, so yeah, for sure. So I think that when we start to, have like multiple people
Stop,
like,
pause it.
this
Oh my gosh, what the heck is happening? Okay. Multiple users. You'd have to have a user's like... Yeah, the book object would change significantly because you'd have to keep track of the last viewed page on a user level, not just a single user level, for multiple users. So that might have to be propagated up to the library level, where we have a user object that, or sorry, we have a list of users, or a hash set of users, or actually no, a hash map of users, where the ID is the key and the user object itself is a value. And at the user level, you'll have a user ID, obviously, and you will have an active book under that user ID, and then a hash map of books that we have read previously and the last page that we viewed on that particular book, where the ID of the book is the key and the value is the number of the last page that we've gone to. So if you did that, you'd be able to structure it in a way where at the library level, you're accounting for all the books, but all the users that are participating in that library. And then on the book level, we extract the property of only having one user within the library from the book class to the user class.
These books might get stored somewhere, for example, in like the SQL table, right? And so then when that happens, we would still want to maybe store like the ID, the title, the content in that table. Now the only changes would be that these sort of customizations are per user. But the book and the content, those are for this entire group of people. And what we can do, I think, is instead of this ID counter being like library specific, we can start identifying books by their IDs on a more like global scale, right? And so, you know, this was kind of just a hack to make this ID thing work and be independent and be like unique. But for example, when you put something into a SQL table, you can also have an ID associated with those entries. And so maybe when we add to the collection, if we see that the title and the content is already in the table, then we instead just return the book that's already in that table or something like that.
Yeah, okay. I think that makes sense to me. Cool. I'm happy with this discussion. I think that we can move on to the second portion. I guess, do you have any last questions on this before I move on? Or last things you want to say?
Yeah, so no last questions. I think that the last thing I want to say is also like it would really depend on like how you implement this like group of people, right? Like, so my immediate thought is like a SQL table, but that doesn't have to be the only way. So I think
there are also a lot of database constraints that would impact the implementation.
Switch gears, and I'm probably going to just comment this out in case you do want to run some code and there's any errors or issues in this. So I'm just going to comment this out. I'm going to leave it here just so we have it to look back at. And I'm going to just indent this a bunch, and we're going to just start at the top of the screen. So don't mind all the stuff at the bottom. All right, so
this is what Ivy League universities you can get into with a 3.6 GPA.
None of them.
Another important component of our book reading system, and this is completely independent, you don't have to reference any of your past code, is I mentioned this is for short stories, and you can have independent indie authors, adding these short stories. So they're going to be, the classics, not going to be those types of titles. They're probably going to be smaller authors. So one thing that we want to avoid in this system is plagiarism. So my task for you is to design an algorithm that would be able to detect the two most likely books that would have plagiarism in them. So like the two most likely
plagiarism detector
for potential plagiarism in a library, and we can define most likely as meaning they have the longest shared common section of text. So
longest shared common section of text.
And we're looking for the two that have the longest
Oh,
shared.
that's tough. That's a messed up question.
How many characters that section of text is. So you can imagine if it's sharing a single word, obviously not an issue, but if it's sharing 6 paragraphs, that's going to be a problem. So does that make sense?
Right. So just to clarify some things, what Keith really means here by substring is that, for example, if I have a string such as learning, what are substrings of this? Well, one possible substring is learn. Another possible is earn, because these are strings that are using characters that belong to this string, learning. Another possible one is earning. Oops. Now you might say, okay, Kylie, all of these are consecutive in terms of the characters. So here, all of these correspond as characters that are next to each other. But in this specific example, Keith is not actually asking, okay, it has to be a consecutive substring.
It could be like Ingrid.
Any substring, which means that as long as the letters are in the correct sequence, you can skip characters if you want to. So for example, here, leg would actually also be a substring. Or,
bruh!
So for example, right here, we have earn as a substring of consecutive characters, but down here,
this is even harder. This makes it even harder.
There's actually a gap of 2 characters in the middle. but this would still be a valid
See,
substring. So
my solution would be to
typically,
backtrack,
We just need all the characters to be in
but there'd be
order,
so many bottlenecks.
left to right. Let's see. Let's start off with kind of a naive solution for that.
Just index every single book.
Is literally come up with every single combination of like substrings for both of these, and then compare those and see which two substrings are the longest, right? But there's a lot of different combinations for substrings, and so I think that we should come up with a more elegant solution. Let's see. So one thing that I'm thinking is we should have pointers that start at the beginning of both strings and kind of move along until one of them detects.
Ooh, that's not bad. That's not bad. Oh, 2-pointer. Oh my gosh. Wait, that's actually not bad.
Shared character. So here, actually, like I would say the first shared character is H. Right. And so here we would have like the 2 pointers kind of be this. Maybe I'll go from the bottom.
Okay.
Here and here, right? And so we look at the next character, and we realize, okay, they're not the same. So then we want to keep going. But one downside of this is that, well, okay, what if I want to start comparing from here and here? Right?
Yeah.
Okay, and then I move it over, and like these two have like 2 shared characters. So I think that there's still this question of there's a lot of different combinations here. So
I think you're on the right track though. I like this.
And then,
these
okay,
thoughts
so,
so
like,
far.
yeah. Okay. Yeah, so I know that here I want kind of these pointers that are moving, and then I just want to be able to align them, right? I think that's the key here is this alignment. And so now I think we just have to figure out how to make that alignment work. I'm kind of thinking like one thing that we could do is kind of have more of a base sentence, and then one where when we have like, so for example, if I made this my base sentence, then in the other sentence I would want to search this sentence for each character. So if I have the I here, then like my first I would start looking from here, and then maybe I would start to look from here, right? But
This is a messed up question. I don't know how I would do this.
Also being kind of long.
This is so much time complexity.
You would have to iterate through this entire thing and do the whole matching.
Exactly.
And so does that make sense? Why that's like maybe not the most optimal solution?
Yeah, that makes sense. And I guess what would be the runtime of that?
O of n squared.
It would be O of n squared because.
Boom.
I guess if we have one sentence O of n and one sentence O of m, it would be O of nm, because for every single character we have
n plus m.
String, m times. And actually, okay, so like my base sentence is like what is the worst thing that can happen is like a base sentence like this, right? And then you're searching. The worst case example would be like something like this, right? Where like if I have an I, okay, well I have to go through each of these. And so yeah, I guess we would have to go through until like they don't match anymore, but then that would just be the very end of this. So like maybe I can add like an A at the end of that. So then I would actually, okay, so then I would say it might be O of n squared m, where n is the
Yeah, I think that makes sense to me.
I think that we should come up with a different solution. I'm trying to think of how dynamic programming would work, because I do think that this might be a dynamic programming problem.
Oh my gosh, bro. If this is a DP pro... This is a DP pro... Oh. Oh, it's that substring problem. No, it's a 2D DP problem. Is it this? Is it interleaving strings? Oh, it might be. No, it isn't. It definitely isn't this.
I mean, you lose me at dynamic. If you ask a dynamic programming problem, you're cooked. You are cooked. Okay, let me think about how dynamic programming works with this. You can make a 2D. Yeah, you can make a 2D array. Oh. It's very similar to that other problem. You have a 2D array of both of the strings, and then iterate throughout the entire array, and match based off of the values to be able to calculate a percentage for plagiarism, kind of.
Sure of how to formulate it.
Yeah, let's I think that you're onto something here. I think
That's a messed up problem to get.
a good way to kind of kick you off here. I mean, I would say let's assume that this is dynamic programming.
It's similar to
long before I ever knew even what a podcast was.
this, right? Longest common subsequence.
Still take it now every single
It's
day.
very similar to this.
Vitamins, minerals, probiotics, and adaptogens in the.
Okay,
I think
Huberman.
as a good starting point, maybe we can talk about subproblems here, and try to define that, and maybe that will help us get to our solution. Or also maybe just define a base case, and maybe that will help us get to the solution. So I think let's assume that dynamic programming can be used here. Let's maybe just start trying to figure out subproblems and maybe a base case.
Yeah. Yeah, so I definitely think that the base case would be pretty simple, and it would just be if there is a match, right, between the two, like if the two sentences equal another, that would be, or okay, let's think about all the possible base cases. So it'd be if there's a match, or maybe we've iterated through everything that we
There's
can.
match, there's no match, and
Or
we've iterated through
like
everything we
an
can.
empty string to non-empty, or even empty to empty, which is when we would know that we're at the very
Yep.
end, right? Yeah. So, for example, with this match, I mean by like read to
Yep.
read, like that would be an exact match. So I think the difficulty of this problem is that we can start anywhere in the texts, right? And I guess if we were trying to recurse through this,
Recurs?
or if we were trying to go through this with dynamic programming.
Okay, there we go.
what I
She
would
realized
try
what
to
she
do
said.
Is,
You could recurse, but
okay, either like S
Yep.
is the start of some substring
Yep.
in this sentence, or it's not, right? And if it's not, then we want to move over and we want to say, okay, well then is like H is a substring or the start of a
Yep.
substring from this other sentence, or it's not. And we want to kind of continue that process. And so if, for example, H is a substring.
But if they want to do that weird like substring stuff, this would be very similar actually. I'm curious.
We would want to figure out.
I need to go
what the longest-
bathroom. That's a dumb problem.
internet providers claim they offer gigabit speeds, but here's the catch. Their upload speeds are often much slower than their downloads. Is that
how many characters can you kind of almost subtract from the two?
And I might jump in here. I think you're on the right track, but I might provide a little bit maybe of more of a launching point, just because I want to be considerate of our time here. I think you're on the right track. I think that let's maybe try to define this like with a single line expression, like a single line recurrence type expression. Because I think that if we can build up subproblems to that final state, that will help us. So let's say we have sections of text A, and I'll put this in quotes here. We have A is one of our sections of text, and B is another one of our sections of text. And basically, that could be hello world or something, and world, this world, something like that. We can assume that basically what we could start doing here is we can imagine that we wanted to find the longest match between A and B, and you could define that as from character index 0 to character index 0 here. So like the longest common subsequence here or substring.
Oh, he literally said the problem. He literally said the problem name. Longest common subsequence. Bro.
Kind of goal state, because we would want to find, if we're working backwards, let's say, we want to find all the way to the beginning. But to help us get there, we could probably see if
She's really struggling through this though. I mean, I would too.
At different indexes. So if maybe index 3, index 5. So like this would be the last character. 5 would be like the last character of B. And I guess keeping this in mind, can we define this in such a way where maybe we can define an equation that would help us work up to that final goal, which would be the entire sequence.
Okay, so if we're using kind of these A/B strings as example, let's define some find substring or something, and we might have string A, string B, right? So, and you're saying, okay, let's do index A and index B as well and start those off with 0. That's going to be our recurrence relation. And so I guess what we'd want to do is find the longest substring between these, and we want to increment one or the other.
Yep.
Right. So like that. Or if string A equals string B, then what we want to do is find the longest substring. We want to increment both of these indices, apparently. Oops, sorry. So I meant string A at index A and string B at index B, like this. So then we want to increment both of the indices, and we want to add 1, right? Because this means that we've found a starting match.
Yeah.
And what we want to do is actually take so here,
and if you want to just write pseudocode here, it's fine too, for me.
Possibility.
Okay, that makes sense to me.
Yeah, so let's just do all these possibilities, and so then if the 2, then we have this like third possibility, right? And
terrible coding conventions.
Take kind of the minimum. Why is this giving me an error? Oh, so then I would want to return the max of possibility 1,
all 3.
possibility 2. Okay, let's write pseudocode. Possibility 1, possibility 2, and then possibility 3. Only if
makes sense to me.
If applicable. And then with our base case, we said that it would be if one of them is at the
That's so messed up, bro. Why would you ask her this?
If IDX A is equal to the length of string A, then we want to return 0. Or
Yeah, she's doing it right though.
IDX B is equal to the length of string B. Yeah, so then for our longest substring, this makes sense now because with each index we have the possibility of shifting it over 1 and trying to compare this sentence with this entire one, or the other one over one, comparing those two.
Yep.
Oh, no.
Introducing Remarkable Paper Pro. The future of paper is here. Bigger, brighter, and in natural color. The ultimate
Indices, or those two substrings, from there on. Or if they are a match, then we also have the third option of moving both of them over. So actually, I should go from here. And
This is such a messed up problem, bro.
this find longest substring repeats all of that on the next character for those two. Then we repeat that process again, and we add one every single time to that. So I think logically this makes sense. Now, one thing might also be that we start to kind of recurse a lot on the same indices, right? Because we're trying.
That's why you don't use recursion, bro. Use tabulation.
Over by one, then we kind of are iterating over through them a lot. So I think that one thing that we could also do is implement some sort of memoization. So here, like maybe. Hold on, I lost the. Oh, here we go. Okay, so then, like, if the memoization is none, then we might want to start this with some sort of.
She definitely could have done a better job in terms of asking questions.
Makes sense is like a list of lists.
Yeah, asking questions to like see what exactly the output of the problem is. She was struggling quite a bit.
Like string A, for example.
Yep.
And then this whole thing by the length of string B. And so essentially I have this table of
yeah, I
string A
understand.
this way and then string B down.
Yeah, I always get confused with the direction of these things, but I understand the goal of this.
First one's row, second one's column. Come on.
Table that stores some of these values.
Yeah.
Yeah.
Exactly. Yeah, and then in order to store that here, then we would want to create like the index A.
She's doing a good recovery though.
Index B,
Very good recovery.
It might be backwards, but we would want to store that essentially, and so then we'd want to add a case of like if like this memo
Has a value. Return the value.
index B, these might be backwards again. If that's -1, then we want to return, or sorry, if that's not -1, then that means that we've already found the answer, so then we just want to return whatever we memorized.
Cool.
Yeah, she's done a good job.
And so at the very end, we'd want to just return memo like that. And let me just think about these indices quickly. So the first one is string B. So actually, if I just swap these two, that should make it work. Because first we'd index into A, and then we'd index into B.
Yep.
So yeah, if I just swap those two, that would work.
Cool. Yeah, this makes sense to me. I guess my last question, I think that this is the approach that I was kind of thinking about as far as dynamic programming goes. My last question is, what would be the runtime of this
No.
Dynamic programming solution?
So the runtime would be O of n. Runtime would be O of n times m, where n is the length of string B, and m is the length of string A. Space complexity would be. What's the recursion stack on that? It would be the max of one of them.
Okay, so here we are going through all of index A, or all of string A and all of string B, right, by incrementing these indices until we hit a base case. So there's no way to avoid going through both of them. And incrementing one but not the other. And so we essentially have to fill out this entire memoization table in order to figure out our answer, right?
Yep.
Which means that it would be O of n.
And then my last question, I know we're running right up on time, is I guess given the context of the original problem was you might have a library of books, how would you leverage this find longest substring to, I guess, find the two most, like the highest probability matches in the entire library of books?
You pass in the string of one book and the string of the other book, and then take that and divide it by the value of what do you divide it by? I would take the length of one book, length of the other book, and divide the longest common substring by the book by either of the books to find the percentage of common subsequences. I don't know how that tells you relatively what it is though.
I think that so here now that we have this find the longest substring with string A, string B, and let's suppose that we changed the implementation of this book to be this like long string of characters for the content. Then that means that what we can do for this find longest substring is just pass in like book A dot content and book B dot content and figure out the longest substring between the two of them, and we can do that for all the combinations of books, unique combinations of books. And if we find, for example, okay, well, so the prompt is to detect the two most likely books that have plagiarism. So we would just return the two books with the longest substring. But maybe we want to say like any books where more than 30% of the more than 30% of the book is, or maybe even like 10%, shares the same substring, then like we might call that plagiarism.
All right, that's all I have. Thank you.
Does your internet bill keep getting higher?
Bro, just cutting her off.
At Google
For your time, I guess quickly, do you have any questions, I guess for me, or any questions about these prompts before I head off?
Okay, so note to the audience that in a normal interview, this would be a time when I would dive deeper and ask questions about, Keith's work or what, he enjoys about the company. And if I, find something in one of his answers that I'm really interested in, I'll dive into that a little bit more. But because this is just a fake interview and I don't really have any questions about Keith's company because the company doesn't exist.
Yep, that makes sense to me, and I did not give you any context really to work with here, so we don't have to repeat what we did with the video that posted on my channel. But cool, nice work. We can end interview. Switch gears.
Yeah. All right. So now let's switch over to the feedback session. Do you want to go through your notes and kind of just share what was good, what was bad, your overall impression?
I think this was an interesting session because I wanted to squeeze as much as possible into this. Like oftentimes you might see like a smaller, fully object-oriented design or a smaller only algorithms, but I kind of wanted to get both because ultimately, from my perspective as an interviewer, I feel like having both concepts is how I actually evaluate your programming skills because a single algorithm doesn't tell me that much as far as your actual talents and like if you'd be a productive member of our team, and also the object-oriented design might not say everything either. So I like the combination, but it was a bit it is a lot of information. So
object-oriented design is probably a little better.
I think solid overall. I think that you hit like the key points. I think some of the things that I'm thinking about with regards to your solution is you hit all of like the key things that I was looking for. So like all books in library, remember active book, remember last page in all books, display page in active book. I think you did a good job with like the basic class structure to capture all of that. I think what I would have liked to see if I was to be like nitpicky and looking for even better solutions is I might look for even further breakdown of classes. So like I think there was some things that could have been broken down further where I think maybe you could have a display class even that could kind of separate the...
That's what I'm saying.
You have the book class that has the title, the content, but then the display class can handle like the font sizes, the characters per page, all of that, and just isolate that function.
That's what I was saying.
So that was like one thing that I picked up on is just I think that it's tricky in an interview setting.
All right, you gave her like 20 minutes though.
Isolate different components and make it easier to fit all together. I think further breakdown of these classes could have been beneficial. And then my other kind of like nitpicky comment and criticism would be like, I think the way that the IDs were structured wasn't necessarily like the most easy to understand.
How?
So I guess providing some more details.
The increment?
I guess adding robustness to these IDs. I think like one thing that would have been interesting, I guess I didn't ask about this specifically, but the concept of like, okay, how could you then maybe if you only had a title in the book contents, how could you maybe grab that ID retroactively, or like would you want to do that? So like maybe some more robustness in how the IDs were set up so that you didn't have to know the system to necessarily get an ID. Does that make sense?
Yeah, for sure. I definitely think that the ID part was one thing where it was like I would have rather just used the title of the book or like some combination of like the title and author. And I think like for example at like an actual library they have like their code or whatever, and they have their system for if it's fiction or whatever genre it is, and then like some combination of I think author that I don't really remember. that they use to ID books, and I think that probably would have been like a better solution is if we had like the title and author. And
yeah, it is
genre,
tricky because
then we
you don't
could
have
come up
access
with
to that
something based
nice
on that.
library. I think the key thing that you did well with the IDs is that you knew that had to be unique. You didn't want to have collisions. And
Bro, who is gonna make
super important because
who's gonna make IDs with collisions?
Headaches for us. Let me see.
That was dumb.
I wrote down. I mean, again, like I'll reiterate, like this was a good solution. This was a solid solution. This would be like something I'm looking for. So like my feedback is more nitpicky and like how could things be improved further. I think another way, and this is kind of similar to breaking things out from, you know, a book class and then a display class to actually put that onto our Kindle Cloud Reader. But I think another way you could have maybe broke this down in a logical manner was when I asked that last follow-up question, which was basically, you know, you might have many users in this, and now we need to be able to, each user needs to have their own like last page for each book and all that. I think that your answer could have been a bit more nuanced there. I think one thing that you could have maybe mentioned is we could have potentially used like superclassing, subclassing to maybe have like, you know, a base book class, but maybe there was like a user book class that built off of that class book that, you know, everyone shared ID, everyone shared title, everyone shared content, but all of those user-specific things could have reused some of that previous code but built off of it.
I don't necessarily agree with that.
Yeah.
That's all I have for the object-oriented portion. Any, I guess, other comments on that section? Cool. And then I think for algorithm solution, I think throughout the interview you did a good job of explaining your thoughts. Super important to anyone listening to this. Don't just write something down. Talk through what you're writing down as you're writing it. That helps me make sure that I know what you're talking about. That makes sure that I know that you're on the right track or off track. So you did a good job both in the object-oriented design as well as the algorithm, just explaining what you were thinking and the pros and cons. So like one thing I liked in the algorithm section is, you know, coming up with a very naive solution to start. I like seeing that kind of iterative approach, see that you're kind of working towards more optimal solutions. So I liked the idea of using like every single substring in these two, but then realizing this is not optimal. I liked then you kind of building and taking that and being like, okay, maybe that's not this approach, but let's take a base sentence and a new sentence, and start going character by character in the base sentence and compare it to the comparison sentence. I think that was you're working towards a better solution. It's going to be better than that every substring approach, but still not quite optimal, and kind of realizing that there was more improvements that could be made. There was a challenge in how to get to the dynamic programming solution. I think we maybe lost some of those details you would normally have included on like the nuance of this and how you might improve it. So like I would have also liked to hear.
As an owner of Walton Goggins goggle glasses, I know how to make slick-looking goggle/glasses, but I have no.
To hear mention not only of verb tense but also like punctuation if we have to, keep that in mind. So if someone changed periods, exclamation points, should those still match or should they not match? All of that. And then just kind of getting to the dynamic programming. I think this was definitely like a challenge trying to figure out how to formulate this. So I definitely had to help a bit more. I think in an optimal, like perfect run through, you would have had gotten a little bit further without me having to prod. But I think the nature of dynamic programming is unless you're reviewing it and like really like studying it and staying on top of it, like in the real world, you don't have to know this type of stuff. You're not coming up and like designing from scratch dynamic programming.
That's what I'm saying. That's why. Why would you ask it?
I'm okay in an interview setting having to prod a bit, but that's I guess a difference between a good interview and a perfect interview is like the nature is I had to provide a decent amount of details and kind of help you get to a recurrence. And then once I gave you that starting point, the launching point of the recurrence, you did a great job running with it. That was definitely like the optimal longest common subsequence or substring type of solution with recursion and memoization to help get us to the optimal. So it was nice to see that once you had an idea of what we needed to do, that you were able to run with it and knew exactly where you could implement an optimal solution. I think that's all I have. I'm rambling on a bit, but hopefully those notes make sense, and I think we can further discuss.
Yeah, I definitely think that this longest substring was a slightly more challenging problem.
It's a hard problem. It's a medium, but it's hard.
Only code or like the ones that I faced in like actual coding interviews. But that's not to say that it's not like a good problem, right? I think it's a really good problem to ask. And
No, it's a terrible problem to ask.
Out,
Who would ask that?
my strengths and weaknesses.
Who would ask that?
I think that one thing that you probably learned from this is that okay, maybe I have certain ideas that are there, and I like needed a little push in trying to formulate it properly. But then once you gave me just like a structure to formulate it, then I was able to take that and be able to run with it, right? Which I think that from an interviewer's standpoint, like when you're interviewing, it's not just about can they do it or not. It's also about how would they, what would an interaction with this person look like, right? And so actually one thing that I really liked about this was that it seemed to be pretty collaborative and it seemed to be very casual rather than like me taking a test.
It freaking feels like that.
What that tells me as somebody interviewing is, oh yeah, like if I do get stuff, like this person would be able to give me a hint, and then I would be able to take that hint and do the rest of the problem. So yeah, I mean, I do wish that I was able to just get that and formulate it, but I think that also dynamic programming is typically tricky like that, and it
is.
It just takes practice kind of to kind of drill that in.
And I think that you make a good point where it's like, this was definitely, the dynamic programming question was a hard question. And I think sometimes once you feel like you're off track in an interview or like, oh shoot, I don't know the answer to this, like I'm screwed, I think realize that you might be purposely given a hard question because then you can identify a larger range of candidates. So like, maybe the tippy top is like, it's instinctual for them to like realize how to solve this with dynamic programming. But I'd say like the strong half of this, they won't know it right away, but they'll be able to work themselves to it. So like, don't get too flustered. This is not to you, this is to a general comment to anyone listening. Don't get too flustered by like getting stuck. You're oftentimes expected to get stuck. You're human, so you're going to get stuck. It's how you rebounded, and I think you did a good job mentioning, you rebounded well, and that's what's important still, like a very strong interview, because you were able to work to the solution, and it was a hard problem.
Yeah. I will also mention, I think one other thing that a lot of interviewers do tend to look for is probably testing. So I do think that, it's a good signal. We were running out of time, but I think for the interviewer, it's a good signal if the interviewee brings up testing and says, oh, like, I like the solution, but in order to verify my answer, I would like to test it, or I'd like to run it. Or
okay, that's valuable.
And I think in terms of what the interviewer is looking for is that they want to see that you're going to be a good software engineer, right? And I think testing is a big part of that equation. And so I think that just mentioning maybe, hey, like these are a few cases that I would have ran through if I had extra time, or here are some of the edge cases. Like I think this might work for most cases, but there might be some sort of edge case here and there that I should have like gone through. I think those would be
that's a great
that should also be a component that you mentioned.
The testing is super important. So seeing that, and it is challenging because we did kind of run out of time. So like I feel like you didn't hit some of those things that you probably would have hit if we had all the time in the world. One thing that's interesting, I saw this on Twitter or LinkedIn as an idea. I don't know what your thoughts are on it. I think that it's a pretty solid idea. I would kind of be impressed if a candidate did this, but I could see it going either way. Is that someone mentioned they were like a data analyst at Google, and in the interview process, like they screwed up, I think, a couple queries, SQL queries, and after the interview, they like, calmed down, like they collected their thoughts, and they like emailed the interviewer like the solutions, like, oh, like I goofed up there. This is how I would have solved it if I had a little bit more time. They followed up with like some solutions. So it'd be interesting. I don't know if you think it would be a good idea or a bad idea. I could see it going over either way, but to like follow up and be like, oh, I didn't get to mention these testing cases. This is what I would have done. I think it's probably situation specific because it could be kind of weird too. I don't know. I'm just throwing that out there as an interesting avenue if you feel like you wanted to redeem a bad interview or something like that and like have some saving grace.
Yeah. Well, I definitely do think that is like I don't think it's necessarily, I don't think it would be a bad idea under any circumstance. I think that okay, maybe your interviewer would never see that and they find it a little bit strange, or maybe they've already submitted their whatever, but I don't think it can hurt. And if anything, I think it shows dedication, and it shows that, you couldn't solve this problem, but you took time and you thought about it some more and you didn't give up, and then you did come up with the right solution and you followed up and communicated that.
Yeah.
Bro, sometimes you just have to give up though.
If I felt like my interview went great, I probably wouldn't feel like the need to do that. But if I feel like, oh, shoot, that was like, I'm so much better than that. At that point, it can't hurt to do something like that, and just keep it casual. Keep it like, hey, I thought of this. Thanks again for your time.
Yeah.
Take care. Like.
Okay, so now after the interview, I just wanted to follow up with you guys. That interview, if I walked away from it, I would have been like, all right, well, there are certain aspects that, just like Keith said, there are certain aspects that signaled, I was probably a strong candidate, but I personally would have walked away from that being like, dang, there are some parts that I probably could have done better on. Like, I needed his help a little bit. I probably could have, eventually gotten it if I just had a bit more time to think, or maybe today was just not my day. And that's just sometimes how these interviews go. You can't do perfectly on all of them. Now, a few notes about my implementation specifically. I use pseudocode because Keith, the interviewer, specifically said it was okay to. And in this specific problem, I really wanted to focus on the algorithm and not really kind of get
Excuse me, sir, would you like to earn income while you learn how to code?
Yeah, dog. Tell me more about that.
DevSlopes helps you earn income while learning.
Get into the syntax of things. And so for me, Python is almost basically pseudocode, so most of it was very Pythonic. But I commented all out because I was too lazy to get that max part working, because I wrote like possibility 3 if applicable, and I was just a little bit too lazy to like actually implement that. And then also there was some underlining that just wouldn't go away, and that was really bothering me, so that's why I also just turned it to an entire comment. Now, some things to remember about interviewing in general. So don't be scared to ask questions. Turn the interview more into a conversation, because that also gives the interviewer a signal of, this is what I'm like as a teammate. This is what it's going to feel like when you're working with me. Now, during the interview, I would always recommend repeating the question to the interviewer, just so that you can check if you actually understood the question, and then from there maybe even ask clarifying questions. And I typically start with something known as the naive solution, which is this is the first thing that I thought of, and this solution would work, but it's kind of this very brute force solution where it might take a lot of time and it might not work. It might time out for these super long strings or these super long data files or this very large array or something like that. So it's very, very unoptimal, but it is a solution. And then from there, that's when I start brainstorming, okay, well, this sucks in terms of timing, so let's figure out how we can optimize it so that we can make it run faster. And from there, if you can find the optimal solution, then you implement it the best way and you are good to go. All right, thank you guys for watching today. Best of luck. If any of you have software interviews coming up, be confident.
It's very difficult to be confident.
So, where your function is becoming linear time is converting the entire set to a lit.
I watched that one already. She doesn't wear glasses at all during the entire interview. Where did they get this photo?
Let's see if I can solve this.
Yeah, her way is the best way. There's a way to tabulate this, though. Almost certain. I wouldn't know. I don't know how to solve this, to be honest. Yeah, this is how you tabulate. Oh, wait. Maybe I do. Int table for new int. Of course, after I look at it, it'll be easy, but let's just see if. Yeah, this is going to be +1, +1. You can do if text1.char at I minus 1 equals text2.char at I minus, or j minus 1. Then table ij equals 1 plus table I minus 1 j minus 1. Otherwise, table ij equals math.max table I minus 1 j table I j minus 1. Return table and yeah, something like that.
Oh. There we go. Let's see this. Wait, I'm so dumb. What am I doing? This is not the problem. shoot. Oops. I'm so used to doing the like is not empty. Oh, this is a nightmare. Actually, is this now? Wait. Wait, what? How do I do this? Oh, oh. What? This is definitely wrong. Okay, never mind. Maybe it's right. Yeah. There's an incorrect calculation right here. Wait. Why is this wrong? There we go. This one's impossible. I don't. Oh my gosh, this one's really hard. You have to like know what to do. That's why. Like these ones challenge you, but they're intuitive. Like you have to have something intuitive. Why would you deliberately make a complicated system?
No, I wouldn't even do that. What is with me using the square brackets, bro?
Hmm. See if I remember these. The Bowen Fords. Of course. N times? Oh, yeah. I'm dumb. Oh my gosh. What's wrong with this? Hell no. Oh, that's why. It's always going to be less than. Bro, what is happening? What could possibly be going wrong? Oh my gosh. What the heck? Why am I doing that? Yeah, I'm done here. I'm tired.